Good morning, students. Let's start with our third lesson. So our third lesson is machine cycle. So you can ask yourself, what is machine cycle? So machine cycle in computing is the basic operation cycle of a computer's central processing unit. That is the CPU. It consists of a series of steps that the CPU follows to execute an instruction. So every instruction a computer performs is processed through this cycle, which involves four main steps. Okay, so one of the first steps is the fetch. Okay, so we have our fetch. The second step is decode. So E is here is E. And the second stage is execute. And the last one is to store. Okay, so let us use real life example for you to understand what I'm saying. So let us use a example like if you want to cook a meal. So let us use a real life example. First of all, let's say I have my machine cycle stage. Okay, that is the fetch. Good. If you want to cook a meal, let's say light soup. First of all, the first stage is fetch. So to cook something, we have to get a recipe from the cookbook, right? So if you get it, then you have to decode. You must read and understand the recipe instructions. Like if you want to cook light soup, so you don't add more garden eggs, right? Like you read about the recipe instructions. Now let's go to execute. So the execute is the actual cooking. Then you cook the food according to the recipe. So when you are done cooking, what do? You have to store. So you store the food or serve the food. Either you serve the food or you store it in a container or any other storage method. Okay, good. Now so let's go a little bit technical. Okay, because we are doing ICT, you must go deeper for you to understand. Okay, so now let's start with the fetch. So the first step is the fetch. Now, what does the fetch do? So the control unit fetches the instruction from the memory. So meaning the CPU retrieves an instruction from the main memory. That is the RAM, random access memory. So the instruction is located using the program counter. So the instruction is being located by using what? Program counter. Okay. So that is the program. This is the program counter. Uses program. So the program counter keeps track of the next instruction to be executed. So that is the function of the program counter. It keeps the track of the next action to be executed. So the instruction is stored in the instruction register for processing. You get it? So this is the instruction register. Normal instruction register. Okay, that's the IR for processing. For example, let me start an example. If you want to add two numbers, let's say if you want to add 2 plus 2, if you want to add two numbers, that is 2 and 2. Okay, so first of all, the CPU first fetches the instruction that tells it to perform what? An addition. So what is the component of the CPU that performs what? Addition. What is the component? So you must write down the answer at the comment section so that I will see. Okay, good. So the part of the CPU that performs what? An addition. Okay, good. So that is the fetch. Good. Now let's go to decode. That is our second step. That is step 2. So the control unit decodes the instruction and directs the necessary data to the ALU. What is the full meaning of ALU? ALU means arithmetic and logic what unit. Okay, so the decode simply here means that the fetch instruction is sent to the control unit. So the control unit interprets or decode the instruction to understand what needs to be done. So if necessary, the CPU retrieves additional data from the memory. Do you understand? So the control unit interprets, meaning it decodes the instruction to understand what needs to be done. For example, the CPU understands that it must add two numbers together because you have given out what instruction. So the CPU must understand that it must add two numbers. Do you understand? Good. So this is interesting. Okay. That's good. Now let's go to our third steps. That's the step 3. Execute. Now, when we talk of execute, the arithmetic or logical instruction. So the ALU executes the arithmetic or logical what instruction because it has told the CPU that hey, do this one for me. Do you understand? Yeah, you have to do that for me. So the CPU carries out the instruction using the ALU arithmetic logic unit or other components. Okay, so the necessary calculations or the operations are performed. So at the execution stage, that is the execute steps, the CPU carries out the instruction using the arithmetic logic unit or other component. So the necessary calculations or operations are performed at this stage. For example, if the instruction is an addition, let's say 5 plus 3, the ALU performs the addition and produces the result as what? 8. Do you understand? Okay, good. Now let's move on to the 4th step. That's the last stage. Okay, that is to store. So the ALU stores the result of this operation in memory or in register. Good. So the result of the execution is stored in the memory. What is the memory? That is a RAM or a CPU register. So the program counter updates to fetch the next what? Instruction. Maybe if you want to perform another instruction, good. Or if you want to add, let's say 3 numbers, the program counter updates to fetch the next instruction. Okay. So for example, the sum 8 is saved for future use, such as displaying it on the screen. Let's say when we were here, that we asked the CPU or we ask the ALU to perform some calculation. Okay, good. So the program counter update to fetch the next instruction. Let's say the next instruction we want to perform addition of what, of 3 numbers. So the next instruction is to perform what, addition of 3 numbers. So it will follow the same what process. Okay, thank you for watching. Okay, good. Thank you.